Hello, sixth graders. This is Mr. Burns, and I am a science teacher in the boathouse. And today we're going to talk a little bit about graphing. Before they do that, I'm going to have you grab out your science notebook and go to your table of contents. Once you're in your table of contents, we're going to put a new entry in there. It'll look like the picture on the screen there. I want you to put in today's date, which is 9-21-20. And then the subject or entry, we'll call it graphing notes, and that'll be on page 3. And again, it'll look just like the picture that you see on the slide there. Now, when you finish all that, I'm going to have you turn to page 3 and title it. At the top of page 3, I want you to write down graphing notes and the date. And then I'm going to also have you put a 3 at the bottom because it's going to be on page 3. Now, as we move forward, talking about graphing, anything that you see highlighted in yellow, you need to copy into your notebook on page 3. So each of these slides are going to have a variety of different sentences and words on it. Only copy the highlighted yellow stuff into your science notebook. All right, so today we're going to talk about graphing in science class. Specifically, we're going to talk about bar graphs and line graphs. And when you hear graphing, you probably think of math class, and you're not wrong. But we also do quite a bit of graphing in science class, and we're going to talk a little bit about that today. Everything that is highlighted in yellow must be recorded in your notebook. So as we're going through the various slides here, if you see something highlighted in yellow, copy that onto page 3 in your science notebook. Reasons to graph. Well, one of the reasons we graph is to show trends. In the graph, you can see how the world population is increasing because of the higher birth rate and the lower death rate. So why do we graph in science? Well, in science, sometimes we want to show the results of an experiment over a period of time. What happens from minute to minute in the experiment, or what happens from day to day over the experiment, and it allows us to kind of examine if the results change or don't change over that period of time. Another reason to graph is to organize information. It can make it easier to read. Looking at the data table, the graph is much easier to read and understand. So if you take a minute to kind of study the graph and the data table, the data table on the left has a lot of numbers and words. And when you look to the right and you see the line graph, that's a picture of those words and numbers there. And it can make it a little bit easier to read and understand. Essentially, you have a picture of your results. When it gets to the point where we're actually ready to graph our data, we use something called TAILS. TAILS is an acronym that helps you remember all the parts of a graph so that the graph is set up correctly. The T stands for title, the A stands for axes, the I stands for interval, L, label, and S stands for scale or size. As a quick reminder, make sure that you continue to copy anything that's highlighted in yellow onto page 3 in your science notebook. The T in TAIL stands for title. Every graph needs a descriptive title related to what the graph is about. As we look at this graph below, there's a title above it. It says favorite graphs. That describes what this bar graph is all about. As we look at it a little bit more closely, it's got bar graphs, pie graphs, histograms, and pictograms, and so forth. The title should always be descriptive, and it should always be at the top of the graph. The A in TAILS stands for axes. You must label the X and Y axes on the graph. Now, a connection you might make to this is in math class. Back when you were in elementary school, you probably studied coordinate planes in math, and you used the X and Y axes to help you plot data points. Now, as we take a closer look at this graph down below, the x-axis is what you are changing and is the horizontal axis. So as we look at this picture, here's our x-axis, and that would be this line right here. This is the thing you're changing. So if we make a connection back to the previous slide, those were the different types of graphs. Like they had a bar graph, and they had a line graph, and they had a pictogram, and so forth. So those are the things that we're purposely changing. Okay? The y-axis is what you are measuring and is the vertical axis. So the y-axis is located right here, and that is this vertical line that goes up and down. And this is, I always think of this as kind of like the results of your experiment, what you're measuring. Like 5 people like a bar graph, 7 people like line graphs, 2 people like pictograms. Okay? Another trick I kind of use to help remember what they are is the letter Y has a little stem on it right here, okay? And that is just an extension of the y-axis like that. So that's another trick that helps me kind of remember where's the y, where's the x. The I in tail stands for interval. The interval is the spacing between the lines on the x and y axes. For example, think about the clocks that hang on the walls in the classrooms at Rosemont Middle School. The spacing between the lines represent different seconds or different minutes or even different hours. It's kind of the same type of deal with graphing. So if we look at the graph on the right and we focus specifically on the x-axis, which is the bottom one, the line that goes horizontally, you can see that it's counting by 20s, where we start out with 20 seconds, or excuse me, start with 0 seconds, then 20 seconds, then 40 seconds, then 60 seconds, then 80 seconds, and so forth. So it's counting by 20s, 20, 40, 60, 80. Okay? Where if we look at the y-axis, the one that's going vertically up and down, it's counting by 100s. So we got 0, 100, 200, 300, 400, 500, 600, 700, all the way up to 1,000, going by 100s. Okay. Now, one of the key things with intervals is that you have to count by the same number for each of the x and y axes. In other words, when I look at the y-axis, which is going up and down, it's counting by 100s, 100, 200, 300, 400, and it has to go by intervals of 100. You can't go 100, 200, 300, 350, 476, 500, 600, 700, 800. You got to count by 100s the whole way up. Just like across the bottom where the x-axis is, we're counting by 20s. We can't all of a sudden go from 0, 20, 40, 43, 56, 60, 80, 100. Got to continue to count by 20s all the way across. The L in tail stands for labels. You must label both the x-axis and y-axis in your graph. Make sure to be descriptive with your labels. So when we look at the bar graph below and we figure out where the labels are, let's look at the x-axis first. It's the line that goes across the bottom. So the label for this x-axis, as I underline it, is types of graphs, which would describe what is above it. And as we look above it, I have a bar chart or graph, pie graph, histogram, pictogram, and so forth across the page. So types of graph describe what those graphs are. On the flip side, as we look at the y-axis, which is the line that goes up and down or vertically, I have a different label. I'm going to underline numbers of people, or number of people. Okay? Got 1 person, 2 people, 3 people, 4 people, 5 people, 6 people, all the way up to 10 people. Okay? So it shows me then that when I look at this bar chart or graph, if I follow the bar up and over, that 5 people like the bar chart. In other words, of the people surveyed here, 5 people, that is their favorite type of graph. Or if I look at the one next to it, pie graph, to follow the bar up and over, we get 2. So 2 people like the pie graph. That's their favorite type of graph. The S in tails stands for scale or size. If we make the graph too small or too big, the graph can be misleading. Sometimes people misinterpret the information on the graph because of its size. When making your graph, it's important to use most of the graph paper so the size of your graph isn't too small. And if you look at the pictures below, those are good examples of graphs that aren't too small or too big. Like I said, if they're too small, it can be misleading. And sometimes if it's too big, it goes off the graph paper. So it's important to space your graph out so that they are the appropriate size. Now that your graph is set up, you have to decide if you're going to make a line graph or bar graph. You will create a line graph when your data shows information involving time. Time can be measured in seconds, minutes, hours, days, weeks, years. Those are all different forms of time. Okay? So we always think line graphs equals data over time. So if we look at the line graph pictured below, it shows data changing over time. What we're looking at is how the population changes over a period of time. Now, what they're doing is they're using years. They start in the 1950, 1955, 1960, 1965, all the way up to the year 2050. And what they're doing is showing how the population changes over time. So if we look at the red line, that's the birth rate. And we can see over the course of about 100 years how the birth rate started to decline. Where the blue line, population, we can see how the population is rising. The line is going up, which indicates it's rising and growing. And then the death rate, the green line, we see how it starts to decline and then it kind of just stays steady as the line starts to kind of straighten out there. So a line graph shows how data changes over a period of time. In this case, we're looking at how the birth rate or the death rate or the population changes over a period of many years. You will create a bar graph when you are comparing 2 or more things. This bar graph compares 4 different types of cereals. So if I look across the bottom, we've got cornflakes, Cheerios, Life, and Kix. And as we look at it, we can see that the Life bar goes the highest, which indicates that that was the most popular, most favorite cereal. We see that the Cheerios bar is the shortest, which indicates that's the least favorite of the 4 cereals. But in this case, again, we are comparing 4 different things, 4 different types of cereal. And when you're making a comparison like that, that means you need to make a bar graph.